concept today with 4 tissue types and expand upon that. So this is an intro into A&P, where A&P stands for anatomy and physiology. What we had left off with yesterday was the nervous system, and let's kind of just review the nervous system. It's one of 2 types of communication systems. There's not only the nervous system, what's the other type of communication system? The endocrine system. Okay, so it's either the nervous system or it is the endocrine system. Which one of these 2 is going to be a long-lasting effect, the nervous or the endocrine system? Okay, so for sure we could put the endocrine system as being a system that is long-lasting. But what's its problem? What's its malfunction? The fact that it's so slow, right? So it's a very slow response system. Now there's the nervous system, which is kind of in direct opposition. This is a very, very quick system. Very quick system. However, it's very short-lasting. So once you send one nerve impulse, you have to send a second nerve impulse if you want the signal to be continued on. How do you transmit nervous impulse? Through what type of cell? So through a neuron. How about the endocrine system? What is its mode of transport? Blood. Yeah, absolutely, yeah. Hormones, proteins, or hormones can be proteins or either steroids. We always kind of think of steroid as being probably a hormone, but proteins can be hormones as well. Cool. So I know I'd really shortchanged, or I hadn't gone into great detail with some of the other classes, but I wanted to make sure that we had that topic 100% covered. The next section in your book talks about, that looks like an E now. What's that is? Feedback mechanisms. Feedback mechanisms. First off, what is a feedback mechanism? There are going to be 2 types. What are the 2 types we're thinking of? Okay, so there's the negative, and there's also the positive form. With a negative feedback, are you enhancing or shutting down a system? So negative feedback results in shutting down. Shutting down a system. Whereas a positive feedback is all going to be about enhancing a system. So what I want you to do real quick is with someone around you, if you'll take maybe about a minute, and I want you guys to come up with an example of negative, an example of positive that perhaps you know or that you could theorize could possibly exist, and maybe it doesn't even have to be 100%, but you think it could be, that is a negative and positive feedback example. So maybe take a minute, work with someone around you, shoulder buddy it, that kind of thing.
Amplifier gain controls and negative feedback system.
Let's try to keep it biologically related,
But that is a negative feedback.
but not in your body.
I mean, same thing.
Mr. Fields.
Yes, sir.
But, for like negative feedback, would an example be maybe when your body overheats when you're sick?
Okay, so let me hear from you guys. What are some of the negative feedbacks that you came up with? Let's see, heart failure. The thing with negative though is that there's got to be something that is causing it directly to shut down, and that there's a reason for that cause. To me, heart failure is caused by like fatty deposits typically, or other like conditions that are environmentally based. I would say anything adrenaline based that could be positive. I think I saw a hand over there. Okay, so that would be a negative or positive? Okay, so full stomach. Okay. How about another one? Here's one for positive. Childbirth.
Can you explain that?
Is contractions start, they become more intense and more close together. So it's an enhancing system. How about another negative feedback control? Can we think of another negative maybe? Because it's always a little bit easier to think of negative ones more so than it is positive ones.
Would you say like when you're scared, you have like, I don't know, I guess it kind of plays into adrenaline, so maybe it is positive, but like, could you say like the opposite of like adrenaline, I guess? Because that like would make you like not be able to think and like shut down. Yeah, like.
So,
Sleeping, stop things.
like you're thinking of maybe like I don't think it would be like epinephrine or norepinephrine, but like an anti-adrenaline basically.
Yeah, I guess.
So like something that would bring an individual down more so than up. Sure. I think you might call that a barbiturate. I don't know, but I think that's what you would call it. You don't hear about much of them anymore. But probably I would say those are moderately decent examples that you could go through. Now, of course, this isn't an exclusive list. This is just a list of some of the major ones, or not even major ones. It's just a couple lists. Let's talk about a couple of other topics. Let's talk maybe about, since we're in this feedback mechanism, let's talk about thermoregulation. Since if you think about it, feedback mechanisms are going to be about regulation. Let's talk about thermoregulation. If you break that down, that's going to be all about controlling or regulating what? Okay, so regulation of body temperature. Okay. And for mammals, there's about 2 different ways that this could occur. Ben, this is for you. Ben, this is for you. There's about 2 different ways this can occur. There is an endothermic way, and there's an ectothermic way. Endothermic. What do you suspect that means? Do what? I'm sorry. Within? Okay. Warm-blooded. So again, in that case, the heat is generated by the body. In the case of ectothermic, this would be a cold-blooded creature, which means they need to gain heat from another source. So I would say that these 2 examples right here, you could put down, you could put maybe human in this top category, or any other mammal, and then like a reptile in this second category. Because typically reptiles will bask in the sun. That's how they get warm. Cool. Now, since this is really a focus on what we're doing as humans, then I think probably we would want to take endothermic and maybe discuss this a little bit more. Again, but with endothermic principles, we're able to generate our own heat. So generation of personal body heat. Now, this expense, because this is expensive, because the heat's not coming from anywhere. It's obviously got to come from somewhere. Where do you suspect this heat is coming from? I mean, you're doing this, right? So there's no heat. You don't get plugged in, right? There's no switch located on your body. You're 98.6 or about virtually all the time. Where could that heat be coming from? Okay, so let's go with that. Now, we've talked about some chemical reactions in the body, correct? And doesn't it make sense? Actually, let's back this up. Can you name an object that does a chemical reaction that gets warm that's not you?
Everything.
About everything. Take a car. Anytime you do combustion, anytime you take an organic source, you combust it with oxygen, and you produce CO2 plus H2O, and you release energy. Remember, this is going to be an exothermic reaction, one that is releasing some heat. What does this look like? Taking an organic substance and combusting it. Digestion, maybe more specifically. Metabolism, cell respiration. This is the general principle of cell respiration right here. So as you do cell respiration, you do produce energy. Now, a lot of that energy goes in production of ATP. True. But if you remember from back in the day, I said that your glucose, which was your organic source, has the potential to make something like approximately 180 ATP. But how much ATP do you make from respiration? About 38. You're obviously having a lot of ATP that's not accounted for. That's like you driving your car and like wondering why the Toyota gets 55 miles per gallon, but your car only gets 5. It's just inefficient. There's inefficiency in this system. And when a system's inefficient, what do you produce excessively? Yep. So you produce the heat. Cool. Now, there's other things that help thermoregulation. So when I jot down thermoregulation, and I think of some other things that maybe could be considered as helpful units. I think of body insulation, circulation, evaporative cooling, circulation, I should write adaptations. Evaporative cooling. What's another way of saying evaporative cooling? Sweat. Behavioral responses. Like, for instance, it's ridiculously cold outside, so you go inside. Or metabolic rate. So any one of these things, if you think about it, are units that could be assisting you or another creature in manipulating their thermometer, their internal thermometer. Maintaining that homeostasis, which of course we remember homeostasis was all about keeping that internal environment in a good spot, not a bad spot. Now, what I'm going to get you to do real quick is I'm going to get you to come up with maybe just like 30 seconds, talk with someone around you. Want to make sure that you understand what we're talking about with each of these. Like, for instance, with evaporative cooling, sweat, which can cool the body. So maybe with the other 4, why don't you just come up with some ideas about what each one is. Want to make sure that, like, when I say the term insulation, you don't, like, you're obviously not, like, wrapped up in fiberglass like you would see in an attic. That's not the insulation we're discussing here.
So like not putting on a coat.
That to me, that would be behavioral. That would be behavioral. Because that's a decision. That's a mental decision you have. So 30 seconds. Go and work with someone around you. Knock it out. Go get it, Captain.
I feel like she should hit. So for insulation, epithelial tissue, would that be like considered insulating
Do
our
what?
bodies and our organs?
I'm sorry. What?
Epithelial tissue,
Mhm.
would that be considered insulation, like for organs, our body? Does that help keep